Hey guys, and welcome back to my channel. Today we'll be talking about adding and subtracting radicals. Before we get into adding and subtracting, let's try one example of where we break down a radical, which is what you need to know. So breaking down a radical, all you basically do is you just want to split it into two sections. The left section has to be a perfect square, like something that you're able to square root. And this one is just the numbers. So basically what we're trying to find is the greatest perfect square that can be divided in 128, because we want it to be simplified the most. And so 128 divided by 2 is 64. So that means that's the greatest perfect square. And 2 is the smallest number. And we can't do that anymore. So 2, 3, 5, 6, those are like the numbers that you can't really you can't square root it anymore. If we still have 8, if this side is 8, we can still break it down to 4 and 2, because 4 is a perfect square. And then after that, you want to put a square root sign on each side, so you know that you're trying to square root both of them. And we know we can square root this one, so we can circle that, only if you want to. You don't have to circle it if you understand. And then it would be 8, and then you keep this the same because you can't square root 2. And so that would be the simplified version of the square root of 128. And so on to adding and subtracting radicals. So when we add and subtract radicals, it is kind of like fractions, because look, when we're adding fractions right here, let's do 1 over 5 and 2 over 5. We always need the same denominator. So similar or alike fractions, how you can add them. So the answer to that fraction would be 3 over 5. So you're basically adding the top, but then you keep the bottom the same. And radicals is like that, because when we add radicals, let's do this for example, the square root of 3 plus 3 times the square root of 3, we basically add the outside number, so that it would be 4, and then is equal to 4, and then the square root of 3. We keep the number inside the square root the same, but then we add the outside number. And yes, this would be 1 right here, because since there's no number, it's going to be 1. It's just like seeing a variable x, there's technically a 1 in front of it. So that's how you do addition, and let's get some more examples of that. The square root of 2 plus 4 to the cube root of 2. So this one, it does have the same number under the radical, but the index is what we call the number right here. This is technically 2, but we don't do 2 because, it's not the same, right? This is 2 and this is 3. So we can't add it because they're not the same. So this equation would not be able to simplify, because the indexes are not the same. Therefore, the number inside the radical technically isn't really the same, because when you cube root 2, it gives us a different answer than the square root of 2. And then let's do the square root of 75 plus the square root of 12. So here we can tell that we can simplify these numbers, because even though they're not the same, we can simplify these numbers to get them smaller. So for 75, we can see that it can be 25 and 3. And then for 12, we can see it's 4 and 3. And we can square root. And then we can circle the ones that we can square root. So this one would be 5 to the square root of 3, or 5 times the square root of 3. And then 2 times the square root of 3. Then we'd add that. And as we can see, after simplifying this, the number under the square root is both 3. And so we can add that. And then that would make it 7 to the square root of 3. And now on to subtraction. So subtraction, just like addition. I don't need to say anything. It's just like it. So if we have an example here, pause the video and solve that. So that would be 6, since we do the math on the outside, and then keep the number in the radical the same if the index is the same, which it is. It's both 2. So the answer would be 6 times the square root of 2. Now we can do this one, 125. Square root of 125 subtracted by 5. So right away we can tell that we can simplify this number. We can't really simplify this number, so we're going to hope that whatever we simplify for the square root of 125 will give us the radical of 5, so we can subtract that number. So when we simplify this one, of course you can use a calculator, but I already have it, so this would be 25 and 5. We can square root both sides and then circle this one because we're able to square root that. And then 5. And you always want the perfect square on the left side, because the left side is where the number will be on the outside of the radical, and then it would be 5. So yeah, it does become a square root of 5 on a 5 on inside the radical. So we can subtract that. So 5 times the square root of 5 minus 5, and then that's equal to 4 times the square root of 5, because we can see this is a 1 here, and the number stays the same inside the radical. So 4 times the square root of 5. Let's try some harder examples of addition and subtraction with radicals. So this one is going to have variables. 27x to the power 5 plus to the square root of 48x5. So basically square rooting or simplifying variables is basically just splitting the variables to make the left side be able to divide by the index. And in our case, the index is 2. And I'll just keep it there to remind you guys. And my trick is that I like to split it up because the number and variables are different in our case of doing the math, but then at the end we would add them together. So I like to split them. And so let's do the number sides first. So 27 would be able to do 9 and 3, and then 48 will be able to do 16 and 3. And then as we can see, 16 and 9 are perfect squares. And so before we actually put that into like 3 to the square root of 3, before we put 3 to the square root of 3 from that, let's do the variables first, because that would be in our answer too. So as I said, you split it into the biggest number that will be able to divide by the index number. So as we can see, we can split this to x to the square root of 4, which is divisible by 2. And then the remaining is x. Same with this side, since this is the same. So that's the way it is. And then we can circle the number that we're actually being divided. And then when we put it into the answer, we would divide it by the index. So divide by 2. So yeah. So this side, this one right here, would be 3x squared, because we divided 4 divided by 2, and we have to put that the divisible number by the x, or the variable that has the exponent divisible by the index, that when we split it would be on the outside of the radical. Then on the inside of the radical is 3, and then the remainder of the variable. And then this side would be 4x squared, basically the same thing, to the square root of 3 and x. So at the end we do combine the variable with the number, but when we do the math, I like to split it up to make it look neater when I show my work. And when we add those two, we can add the outside because they are like terms. You should know that from like solving equations. That one's pretty simple. And then of course the number on the inside, the radical, stay the same. So the answer is 7x squared times the square root of 3x. Let's do one more example. So this is an example where we already have numbers on the outside. And so what we're going to do with that is that after we simplify what's inside the radical, we'll multiply what we put on the outside to what's already on the outside. So when we do solve this, leave the outside stuff alone. So just think about the think about the radical only. So if we're doing the square root of 4, you just think about that. And then once found the values that we're supposed to bring out, then we will multiply that with what's already on the outside. So the square root of 40, we can put that into 4 and 10. And we can circle 4. square root of 90 would be 9 and 10. 10 seems like a number that you can split up again, but no, actually, because the only factors of 10 is 5 and 2, and 10 and 1 technically, but obviously that's not going to work. 5 and 2, but none of those numbers are perfect squares. And we can start with 9, and then 160, 16, and 10. And as you can see, they all have 10. So we can put the number that we got. So that's 2 to the square root of 10 plus 3 to the square root of 10 plus 4 to the square root of 10. But we left out the numbers on the outside. These numbers right here. These numbers. And so we're going to have to multiply them back. So the numbers that we have on the outside, so it's 2, 3, and 4, we're going to have to multiply it to the ones that was outside of the radical that we split up. So 2 would be multiplied with 6x. So that would be 12x to the square root of 10. Then 3 times 2 to 3 times 2x, which is 6x to the square root of 10. And then 4 times negative 3x, which is minus 12x to the square root of 10. And then, again, we do the math on all the outside terms, and that would give us 6x to the square root of 10. And so that's how you add and subtract radicals.